In this video, we're going to talk about finding the zeros and their multiplicities of polynomial functions. Okay, so I'm going to read this definition, we're going to look at it, and then I'll try to explain it a little more clearly. It says the number c is a zero of multiplicity k of a given polynomial if and only if k is the largest integer such that x minus c to the k is a factor of the polynomial. Okay, so what this is saying is if you have a polynomial written in this form here, okay, you have it all factored out, all right? What would make each of these zero are the zeros, okay? So basically what we mean is like if we were to set each of these equal to zero and find each of the, if we were to like solve it like we have in previous examples, those are going to be our zeros. We can also think of these as the x-intercepts. So if you have some graph that looks about like this is going to come up more later, but if we have some graph like this, these points are actually going to be the x-intercepts. So when you find the zeros of a function, you're actually finding the x-intercepts. It's where y is equal to 0, or I guess in this case, f of x is equal to 0. So that's really what we're doing here. All right, but the multiplicity of each of these zeros is this number right here. It's the exponent. All right. If there is no exponent, then you can just think of putting a 1 there. Okay, it means there's one of them. Okay, to see why we can think of it as a multiplicity, if we have maybe x plus 3 to the third, this is really x plus 3 times x plus 3 times x plus 3. So really you're kind of thinking of it as like there's 3 zeros at 3, so to speak. That's not quite right, but that's kind of how you could think of it, at least in terms of the multiplicity. There's 3 instances of x plus 3 here, okay? And later, when we're graphing these functions, this is going to become really helpful for determining how this is supposed to look. So let's go ahead and do this example. We have f of x is equal to x plus 5 squared plus x plus 7 to the first. We already put that there. And then we have x minus 11 squared. So the first thing we do is we find the zeros. So if it's of the form x minus c to the k, we could also rewrite this as x minus negative 5 squared times x minus negative 7 times x minus 11. Let's get all this over. Times x minus 11 squared. Okay? That's another way we could do this. Therefore, our zeros, we said, are the number c. So if it's of this form here, we'll have x minus a negative 5. So our zeros are going to be negative 5. They're going to be negative 7, and they're going to be 11. Okay, and you can check this by plugging in negative 5, negative 7, or 11 and seeing what you get for f of x in the end. If you plug in negative 5, you'll get negative 5 plus 5, which is 0, and it doesn't matter what these are going to be over here because the whole thing is going to be equal to 0. So these are the zeros for your function. And their multiplicity, again, comes from this exponent. So for negative 5, its multiplicity is going to be 2. For negative 7, its multiplicity is going to be 1. And for 11, its multiplicity is going to be 2 again. Okay, so really straightforward, very simple. That's all we're looking at here. So let's look at one more example. We have g of x is equal to 6x times x plus 13 times x minus 5 squared times x plus 9 to the third. Okay, so let's go ahead and rewrite this so we can get them all of the form x minus c. So if you ever have just an instance of x here, you can actually rewrite this as, we're going to leave the 6 out front alone. That doesn't have anything to do with any of the zeros in its multiplicity. But if we have just an x here, we can actually write this as x minus 0, okay? Or if you had x squared, you do x minus 0 squared. But in this case, we just have x. So we'll have x minus 0. Then we'll have x minus a negative 13. Then we'll have x minus 5 squared. And then we'll have x minus negative 9 to the third. All right, so let's find our zeros now that we can look at them this way. Again, this 6 doesn't mean anything here, at least not in this context. So then we have x minus 0. So that means 0 is going to be one of our zeros. That means negative 13 will be one of our zeros. That means 5 will be, and that means that negative 9 will be. And now let's look at the exponents for each of these. So x minus 0, that's to the first. So we're going to have 1 for the multiplicity for that. X minus a negative 13, that again also has a exponent of 1. So that means negative 13 is going to have a multiplicity of 1. And then we have negative 5, or we have 5. That means that with a exponent of 2 here, so its multiplicity is going to be 2. And then we have x minus negative 9 has a multiplicity of 3. So there we go. We found the zeros and the multiplicities of each of these zeros for these given functions.